Hello everyone, welcome back to my YouTube channel Learn with Sumi. In this video, we are going to learn Linear Algebra Module 5. In this, we are going to get started with the introduction, of this Linear Algebra. We are going to get started with the what is matrix. I'm damn sure you must be aware of like what matrices are or what is matrix, other pronunciation, but we Indians usually pronounce it as matrix, right? So here you can see the elements are arranged in the rows and columns form. So here you can see these are the columns individually, one column, column 1, column 2, column 3, and so on till column n. Okay, and the first number here, it is representing the row. The second number, it is representing the column. So first row, first column, element of first row, first column, element of first row, second column, element of first row, third column, so on till element of first row and nth column. Okay, likewise moving till element of mth row and first column, element of mth row and second column, element of mth row and third column, and so on till element of last element, that is going to be element of mth row and nth column. Okay, so this is m cross n or m by n matrix. This is the order. What is the order? Order is m by n matrix, the order of these matrices. So basically, why are we using this can be arrangement of any element. Consider arrangement of cups you have it in your home, or anything that is arranged in like rows and column form. So you can consider arrangement in a matrix form. Okay, so we'll go with the definition now. Here we have a set of mn elements, right? I already discussed here. A set of mn elements written in an array of m rows. These are rows 1, 2, like first row, second row, third row, and so on till m row. So m rows and n columns. So first, second, third, until the last n column. Okay, n column embedded in either this bracket or this bracket. This is normal square bracket, and this is the parenthesis what we usually use, is called a matrix, and of order of m by n. Okay, this is the order of m by n. So okay, also when we have few more cases here. Okay, I hope you understood what matrix is. And if consider one scenario wherein m is equals to n, that means number of rows is equals to number of columns. So here it becomes what? Square matrix. This becomes square matrix. For example, I would like to show you here, like I have matrix. Consider, let me not consider the representation like a and b. Let me consider take the numeric values 1, 2, and 3, 4. Okay, so I already took 1, 2, 3, 4. So this is my row 1 and this is my row 2. This is my column 1 and this is my column 2. Here you can see I have 2 rows, correct, and I have 2 columns, which is equals to 2 columns. So can I say this as a square matrix? This could be like 3 rows, 3 columns, 100 rows, 100 columns, 4 rows, 4 columns, anything. Okay, so such matrices are square matrix. Now again we have something called as row matrix. Okay, I discussed square matrix. Now we have something like row matrix. So you might know what it is, but still I'm going to explain. Okay, for the one who don't know, and for you, for the ones who know, it is just kind of a revision for you guys. So the order is going to be 1 cross n or 1 by n. So here you can see row matrix. So there is only one row, and the column could be any number of columns, right? So only one row means here you can see 1, 2, 3, 4, anything. 6, so on till n. But here I have like only one row. Correct? So this is called as row matrix. I have many columns but just one row. So I can call this as row matrix. And there is something called as column matrix too. Okay, column matrix. There is something called as column matrix too. So in column matrix, there could be like multiple number of rows, but only one column, 1, 2, 3, so on till anything. Okay. Let me consider it as m only, why 4? Okay, it will be confusing. So let me consider m. So here I have like row 1, row 2, row 3 and till row m. But I have only one column, C1. I have only one column, and hence the order of this is what? M cross 1. Correct? M cross 1. So hence this is our column matrix. So here for example I'm taking like 1 to 1 now commas 3 4. So this is nothing but 1 2 3 4. 4 columns I have. So 1 cross or 1 by 4. And then here column matrix. So this column matrix, I have like only one column and multiple rows in this. So let me take it like real example. 1 2 3 4 5. Okay, this is only one row. So first it is represented in what sorry, this I have 5 rows and only one column. So 5 by 1. This is the order of the matrix. Okay. Here let us consider a square matrix A of order n. Okay, so the order is n by n. So here you can see A11, A22, A33, A44 and so on till ANN. So this diagonal in a square matrix, okay, A11, A22, A33. So it is called as principal diagonal. Okay, and if you add up all these elements, okay, the diagonal principal elements or the principal diagonal elements, if you add up these elements, it is called as trace of A. I hope you understood this much, and we will see now what is upper and lower triangular matrix. So when we say upper triangular matrix, so we have the elements, you know, for upper triangular matrix, below this principal diagonal we will have all the elements as 0, and here it will be non-zero elements. Here it will be non-zero elements. Here all the elements will be 0. So it will call as upper triangular matrix. Okay, vice versa. So here you can see above the principal diagonal we are having all zeros, but here we are having non-zero elements. So this is going to be lower triangular matrix. I'll just give you example for these. Okay, so it will be very much clear for you guys to understand. So for upper triangular matrix, I'll just write it like upper triangular matrix, just a short form for you to understand. Example for this is, consider 1 2 3. Okay, 0 0 4 5 6. So here see, this is the square matrix 3 by 3. So this is the principal diagonal, right? This is a principal diagonal. So below the principal diagonal all the elements are 0, and above it, it is what? It is a non-zero elements. So it is what? Upper triangular matrix. Okay, upper triangular matrix. So now for the lower triangular matrix, we have the example like 3. Let me consider 3. Okay, 4 5. So 0 0 0 4 5 6, 7, 8. So this is our principal diagonal. This is our principal diagonal, and above the principal diagonal we have all zero elements, and below that we have non-zero elements. So this is called as lower triangular matrix. I hope you understood this much. Now this is diagonal matrix. Okay, so diagonal matrix, so I'll just write down the definition of this. A square matrix itself, okay, a square matrix is said to be diagonal matrix if every element, okay, if every element other than the principal diagonal, okay, the principal diagonal elements are 0. So what do you understand? It has to be a square matrix, okay? A square matrix, it is called as a diagonal matrix, okay? If every element, square matrix, is said to be a diagonal matrix if every element other than the principal diagonal elements are 0, okay? For example, I'll just write down the example here. For example, 2 cross, if we take the 2 cross 2, so 4, 0, 0, 5. Here you can see this is the principal diagonal. This is the principal diagonal, and other than the principal diagonal, we have all zeros. So this is diagonal matrix, okay? And when we look at 3 cross 3 or 3 by 3 matrix, we have like 2, 3, and 4. So here 0 and 0, 0, 0, 0, 0. Okay, so I'll just use the highlighter. So this is the principal diagonal. Okay, so other than the principal diagonal, all the other elements are 0, and the principal diagonal elements are non-zero. So this is called as a diagonal matrix. First condition, it has to be a square matrix. A square matrix is called as a diagonal matrix only if the principal diagonal elements are non-zero and all the other elements are zeros. Now we'll move forward and see what is scalar matrix. Okay, scalar matrix. If every element, for the definition for this is, if every element of diagonal matrix is the same, okay, then it is called a scalar matrix. Okay, for example, I'll show you what it means. I have a diagonal matrix. Of course, the diagonal matrix has to be a square matrix. So let me consider 2, 0, 0, 2. You can see here the principal diagonal elements. Okay, this is a diagonal matrix, of course, and the principal diagonal elements are same, right? I'll take one more example. 3, 0, 0, 0, 3, 0, 0, 0, 3. Okay, here you can see again this is a 3 by 3 matrix, and here the principal diagonal elements are same, correct? So all the other elements are zeros. So hence this is called as a scalar matrix. Now we will go for, I hope you understood the scalar matrix. Now we will see what is unit matrix or identity matrix. Okay, unit matrix or identity matrix. Okay, I'll just write down the definition. So a scalar matrix in which, okay, in which each diagonal element is equal to unity, means 1. okay, is equal to unity. That means 1 is called unit matrix or identity matrix, okay, and that is denoted by I, okay. This is the denotion of identity matrix. For example, I'll take 2 by 2 matrix 1 0 0 1. So here you can see this is a scalar matrix, and the principal diagonal elements are unity, or it is 1, okay, or 1 0. I can take 3 by 3 as well, okay. Here you can see the principal diagonal elements are all are 1. So this is called as what? Identity matrix or unit matrix. The next we have is null matrix, okay. The next we have is null matrix. So from null itself you can understand what it means a matrix which contains like all zeros, everything is null. So I'll just write down the definition. It might ask you in a question for 1 or 2 marks, so no problem, but having the knowledge of these matrices is very much important, as you are going to solve the many matrix problems. So a matrix having all its elements equal to 0, okay, is called null matrix. For example, null matrix, you understood? Matrix having all its elements equal to 0 is called null matrix. And we will go with the example now, okay. So the example is, you can see 0 0 0 0. This is 2 by 2 matrix, or if you go with 3 by 3 matrix, this is going to be like this, okay. This is our null matrix. All the elements has to be 0. It could be a square matrix or a non-square matrix. It does not matter, okay. Now we have transpose. So how do we get the transpose of a matrix? Null matrix we discussed. Now we will see transpose of a matrix. Okay, and that is denoted by A dash. This is called as A transpose. So transpose of a matrix is excuse me, it is obtained. I'll just write down the definition. Transpose of a matrix A is obtained by interchanging their rows and columns, okay. And transpose of a matrix A is obtained by interchanging their rows and columns, and is denoted by A dash, that is A transpose, where A is a given matrix, right? Where A is a given matrix. A is a given matrix. No need to mention this because I already have given here. Still, where A is a given matrix. I hope you understood this much. So, if we take like A transpose and transpose of A transpose, then it will give us our original matrix, correct? I hope you understood. A transpose, I'm interchanging rows and columns once. So I'm obtaining A transpose, and again I'm interchanging rows and columns, so it will give me my original matrix. So for example, I'll show you. Okay, let me consider a matrix A, and I have like elements 1 2 3 4 5 6, okay, and transpose of the matrix A I can write it as 1, 2, 3. This row interchange to the column. And then the second row, I'm writing it as a column. I hope you understood. That is the transpose of the matrix A. Okay. And if you want, like, let me consider one more matrix B. Okay. Here I have like -1, 2, 4. And transpose of the matrix B, I can write it as -1, 2, 4. Correct? Now we will see what is symmetric matrix and what is skew-symmetric matrix. Okay. So here I'll write it down. Symmetric matrix and skew-symmetric matrix. Okay. So square matrix A. Consider A. It is equals to the transpose of a matrix A. Then it is symmetric. And if this matrix A is equals to the negative of the A transpose, then it is called as what? Skew-symmetric. I hope this is understood. For example, I'll give you for the symmetric matrix 1, 2, 2, 3. And if I'll take the transpose of this matrix, if I take the transpose, it is going to be 1, 2, 2, 3. Correct? Isn't it same? So A is equals to A transpose. So I can say this is a symmetric matrix. We'll see one more example for symmetric matrix. So one more example for symmetric matrices. Let me consider 1, 4, 2, 4, 5, 0, 2, 0, 7. And if I take the, let me consider this as a matrix P. So transpose of matrix P, if I take, so this is my first row. So I'm writing it as column. Second row, writing it as column. Third row, writing it as column. Okay. So you can see matrix B is equal to transpose of itself. So I can say this is a symmetric matrix. But when it comes to like skew-symmetric matrix, I'll give you the example. Okay. Let me consider matrix A. So 0, 1, -1, 0. Okay. And if I take the transpose of this, so it is going to be, okay, 0, 1, -1, 0. So you can see this is the negative. A is equals to negative of A transpose. So I can call this as skew-symmetric. Right? And let me consider one more example. Okay. 0, 2, -1, -2, 0, 4 and 1, -4, 0. If I take the transpose of this, so it is going to be 0, 2, -1, -2, 0, 4 and 1, -4 and 0. So you can see B is nothing but negative of the B transpose. So I can call this as skew-symmetric. Okay. I hope you understood this much. In the next video, we will see algebra of the matrices, how to add, subtract, find the product of the matrices, etc. Okay. Thank you so much for watching this video. I hope you found this video very much helpful. Do not forget to share it with your friends as they can also get benefited. And comment it if you have any doubts. Okay. And if you want me to do more problems on matrices. Thank you so much for watching.